Now, this exact wording of the question is the real-life application of slope. When they talk about a 1 unit change, more specifically increase on the x-axis, in other words, when we're talking about slope being rise over run, the run is the x change, and there's indicating that would be a change of 1. So that is the concept of slope. When they say, what is the change in y for every 1 unit change in x? So in order to determine the slope, we really want to determine a line of best fit. So I don't have a very steady hand, but we're going to go ahead and just do a approximation, something like that. And then I'm going to pick 2 ordered pairs that fall on that line. Well, right away, I can tell it's a negative slope. I'm not going to waste any time with C or D. I know it should be negative, and we could probably reason through these two, but if we want to just kind of plug it into the calculator, what we could do is identify, well, this looks pretty close to a corner, and say maybe it's 30, 50 as an ordered pair. This one looks fairly close to 40, 25. So let's go into Desmos, and we're going to go ahead and take these 2 ordered pairs that we would have put on our scrap piece of paper at this point, and we're going to press the plus symbol, choose table, and just type these in. So 30 for the first x, 40 for the second, and then we'll go over to the y's, we'll type in 50 and 25, and then when we click this regression symbol, by default it goes to linear regression, and that's actually what we want, is linear regression. So we'll just keep it like that, and notice you get this equation that we could put even here if we want, but the key thing is that you have the slope is negative 2.5. So the correct answer is B.